Now let's prove that that left outer join is actually a left outer join. First of all, let's count the records in the show table. We have 147 records in the show table. Now let's go and count the records in the category that do not have any category entries in the show table. In other words, categories that do not exist as shows. This gives me 27 records. If I take 147 and 27 and I add them up, I get 174 rows. This means that there are 27 categories that do not have shows, and they are being reported in the previous query. We could get really fancy with the query, and it looks something like this. Do not worry too much about the subqueries and the syntax at the moment, but this can just show you how clever you can get with SQL. I get the same total, 174. I have two subqueries. I've added the amounts together, pulled them from Dual, and renamed the column title as total. So that's the left outer join. Let's go on to the right outer join. The right outer join is simply the opposite way around to the left outer join. Now we have a different example, and you can see that the plus sign in the parentheses is on the other side of the comparison condition in the where clause. The ANSI format simply lists right outer join instead of left outer join. It's important to note that I could have simply changed the order in which I retrieved from these tables in the left outer join example and called it a right outer join. I could simply have taken s.category_id and placed it on the left and c_category_id and placed it on the right. I could have done a similar thing with the ANSI form. But we'll stick to another example. Now let's go and look at some examples for the right outer join with this statement we have here. So I've got my script again. I'm going to do the natural join between the act and supporting act table. I get 8 rows. Now I'm going to do an outer join. Remember, right outer join, the left side is deficient in information. In other words, there are more acts than there are supporting acts. So I'm going to find a lot more acts than I do supporting acts. I get 59 rows. Let's go back to the script again, and we'll just run through with the ANSI version. I get 59 rows as well. Now let's go and prove that right outer join. I'm going to do the same process I did with the left outer join. I'm going to count the rows in the supporting act table. I have 8. I'm now going to count all the rows in the act table which do not occur in the supporting act table. I have 51 acts with no supporting acts. Now I'll do that same long query, and I'll simply add the numbers together, and I get 59. As you can remember, my original outer join, right outer join, contained 59 rows. Now let's go and look at the full outer join. As you can see, the full outer join simply selects everything. However, note, a full outer join is not a Cartesian product. It doesn't take every row and select every other row in the other table. Also note another important point: you cannot execute a full outer join in the Oracle proprietary format. As a side issue, I wouldn't recommend doing full outer joins. It's very, very unlikely that you would actually need to execute a query like this. It may be better to break it into parts. It would be a lot more efficient. However, that's besides the point. The full outer join selects the intersection, plus all the rows in the first set, not in the intersection, and all the rows in the second set, not in the intersection. The point is it doesn't join them all together. So it's definitely not a Cartesian product. So we don't really need to display an Oracle proprietary version of the full outer join because, as I said, it doesn't exist. Here we have a full outer join, in fact 2 full outer joins between 3 tables: the venue table, the show table, and the act table. Note how I've used the ON clause to force the use of the matching between venue ID and act ID within the different joins. Let's look at some examples. So let's do that join we had displayed. So we're doing two full outer joins between venue, show, and act. And this is the result we get. Quite a few rows. And it was kind of slow because it is complicated for Oracle to deal with that. Now, why can't we use the Oracle proprietary format? Because the outer join operator can only be used in very specific circumstances. As you can see, I have some scripts and I have some errors. I'm just going to run them and try to explain them. Here what I've done is I've tried to outer join between more than two tables, which is really what I would need with this multi-table full outer join. It's telling me that I cannot do an outer join between show and venue and show and act. It just won't allow me to do it. The same applies to this version, which is not the same join, but it makes the point. I can't put the outer join operator on both sides of the where clause, which is really what a full outer join is. Both sides are deficient in information. So the full outer join, as far as the Oracle proprietary version of join syntax is concerned, simply doesn't exist.